Solving quadratic systems. Number 1. Solve the following system by graphing. So let's take a closer look at that. The first equation is a quadratic equation, and we need to find the vertex and the y-intercept so we can graph it. The x-coordinate of the vertex is negative b over 2a. A is negative 1, and b is 4. Substituting those in, we get negative 4 over 2 times negative 1, which gives you 2. So that's the x-coordinate of the vertex. To find the y-coordinate, substitute 2 in for x. So negative 2 squared plus 4 times 2 plus 3 equals 7. So our vertex is 2, 7. So now let's find the y-intercept. In the y-intercept, the x-coordinate is 0, so substituting 0 in for x, and we get y is 3, so the y-intercept is 0, 3. Now we can graph the first equation. So click to enlarge the graph, choose the parabola, and my vertex, we said, was 2, 7. Now the y-intercept is 0, 3, so go to 0, 3. So there's my graph. Always start by graphing the vertex. Now let's graph my second equation, which is a line. So I have y equals 4x plus 3. Y-intercept is 3. And I go up 4, 1, 2, 3, 4, over 1. So then I press save, check answer. Now the solutions, which is the intersection point, is 0, 3. You can see right there, that's where they intersect. And that's number 1. Number 2, solve the system of equations. So let's take a look at that. So I'm going to solve this system by using substitution. They both equal y, so I can set them equal to each other. Now I'm going to bring everything over here to the left because I want everything to equal 0. So I'm going to add x squared to both sides, subtract 13x from both sides, and add 3x to both sides. Doing so gives me 2x squared minus 8x plus 6 equals 0. So now I need to factor this, so let's do that. So the first thing I'm going to do is factor out a GCF, which is 2. So divide everything by 2, and I'm left with x squared minus 4x plus 3. Now I factor this. I'll look for numbers that multiply to 3, but add up to negative 4, and I'll have negative 1 and negative 3. So write x minus 1 and x minus 3. So now we set each of these factors equal to 0. So we have 2 equals 0, x minus 1 equals 0, and x minus 3 equals 0. Well, obviously 2 does not equal 0, so we don't have to go any further with that. But we add 1 here, and we add 3 here, and we get x equals 1 and x equals 3. Now we got to find the y-coordinates, so we got to substitute 1 in for x and 3 in for x. So let's do that. I'm going to choose the first equation to do that with. So substituting in 1, I'll end up getting 1 squared plus 5 times 1 plus 3, which equals 9. So the first solution, or place at the intersect, is 1, 9. Now I'm going to substitute in 3 for x. 3 squared plus 5 times 3 plus 3 gives you 27. So the second one is 3, 27. So now let's type both of those in. So 1, 9 and 3, 27. And that's number 2.